In this presentation, we're going to look at logic and using truth tables to prove that two statements are equivalent to one another. So use truth tables to prove that the following statements are equivalent to each other. Let's just remind ourselves what the symbols mean. So this means logical OR. This means logical AND. That there means logical NOT. This is also an operator to indicate equivalence. It's sort of like equals. And that is and not over there. So P or Q and not P is equivalent to P and not Q. So we're going to use truth tables to perform this calculation here. So I'm just going to scroll down here. Now we have the truth table set up here. First off, I'm going to put in the base values for Q and P. I'm going to start with Q first. 0, 1, 0, 1, 0, 0, 1, 1. Now, first off, I'm going to perform this part of the calculation first. I'm going to work on this side here, the left-hand side. Then what I'm going to do is I will look at this side here, the right-hand side here. So these three middle columns correspond to the left-hand side. I'm going to color code them red. So P or Q. So we're going to look at P and Q over here and check whether or not either of them are equal to 1. So at least one of them has to be equal to 1. So 0 and 0, neither of them are equal to 1, so that's going to be 0. Here, Q is equal to 1, so that's 1. In the third row, P is equal to 1, so we get a 1 there. And both of them are equal to 1 down there, so that's 1 as well. Now, not Q is the next column we're going to look at, and we're going to look at the values here. So if we have a 0 here, the not Q is 1, and if we have a 1 here, the negation of that is 0. So the negation is the operation for the not statement. So 0, that gives us a 1. We have a 1 in Q, that gives us a 0 there. 1 and 0. Now we're going to perform logical AND here. This is the logical AND statement here. So what we're going to do is perform the logical AND operation on the two columns that we've just done there, the two red ones. So both of them have to be equal to 1. So 0 here, 1 here. Only one of them is equal to 1, so that's 0. Like same again, 0. Both are equal to 1 over here, so that gives us a 1 there. And that is a 0 there because we have a 1 there and a 0 there. So 0, 0, 1, 1. Now this is important. We're going to use this row later on to sort of look at this over here to compare to this this column over here. Now what we're going to do is look at this column first off. And what we're going to do is P and not Q. So we're going to look at this row here and that column there and that column there. And what we're going to do is check where we get 1 for both values. The value of 1 in both columns. So we have a 0 here and a 1 here. There's a little dot there to indicate what I'm looking at. So we have 0. We have a 0 here and a 0 here, so that gives us a 0. We have a 1 here and a 1 here, so that gives us a 1. And a 1 here and a 0 here, so that gives us a 0. Okay, so that's the left-hand side done and the right-hand side done. What we have to do at the end is just sort of point out that this column here and this column here are identical to one another. So that means that the left-hand side is identical to the right-hand side, which is to say that they're equivalent. And that ends the presentation.